Okay, I'm starting recording on this. This is round 1A of the 2020 Google Code Jam. This is my screencast, and it's going to start in 4 minutes. So, got some nice comments on my last screencast, so thank you. I'm glad some people appreciate it going up. There are definitely better people out there doing screencasts, and I'm sure everybody watching this probably already knows that Irito has some really good screencasts and explanations of problems. But if for some reason you didn't know that, then check him out. And I think there are a couple of others who do a good job of breaking down the problems. But yeah, so I mean, this is not going to be a perfect description of how to solve the problems. This is going to be watching me flail while I try to figure out how to solve the problems. Although it's round 1A, I don't really expect any brain teasers here. I guess we'll find out. It is a timed contest, so there are 2.5 hours to go. So regardless of what happens, I will be done in 2.5 hours, but hopefully I'll be done sooner. All right, I'll just create some templates. 2020 round 1A. Google Code Jam always uses the same format, so. So there's no real need for me to go full tilt on this. I'm going to slow down and explain my solutions if I can. I mean, chances are pretty low I won't qualify, and there are 2 other chances even if I don't. If for some reason I don't manage to qualify in round 1A, so there are plenty of chances. Round two is also not too bad, although there are no do-overs. And of course, round 3 is the one that is really tough and where I will really have to focus in order to get a slot at the finals. All right, so we've got a minute to go. Sorry, 2 minutes to go. Yeah, I do stress out a bit about these screencasts because there's always the chance I will look incredibly stupid in them, miss a very obvious solution that everybody and their grandmother knows immediately as soon as they see the problem. But whatever. I mean, I'm 20 years past the point where my pride really matters. So, and there's always the chance that this will prove educational. And hey, maybe I'll have a good round 3, and then I'll have a good round 3, a video of a good round 3 that I can point to in later years. Who knows? Stranger things have happened. I have loved programming contests all my life, and it's been an honor to be able to continue to participate in them by being a finals judge for the ICPC every year. And while that hasn't really kept my skills as fresh as they would otherwise be, it's definitely a community I'm glad to be part of, even if it's only peripherally. Well, 10 seconds to go. All right, let's see what we're in for. We are in for nothing. Okay. You can do it. You can do it, round. I believe in you. Not a good start. All right, so 3 problems. The interface isn't hiding a 4th problem. Doesn't look like it. So pattern matching. All right. Wait, so why can't you just use star to match everything? That matches all those patterns at once. Oh, I see. They're giving us the patterns and we want to. Okay. Okay. Okay, so this is so a greedy solution isn't good enough because if you have a star at the beginning, like say on some other string you're matching star C, and then your next thing is R, then you might want to match something like CACR, say on another string, and if you immediately go from this star to the C, then you'll say, oh, this doesn't match, and then you're screwed. So you'll want to stay on this star as long as possible. So let's see. Okay, so I am just finding a string of letters. Now hold on, how? So they're at most 5,000 characters. And we have up to 10,000 letters. So, I mean, that's, yeah, we are not going to need 10 to the 4th letters. They're just putting that limit so that, we don't overflow the output. Okay, so this isn't as trivial as I expected for a first problem. I think I am missing something. So obviously I'm trying to match. I mean, I'm trying to match all the letters I can, but it's only. But say I want to put these two strings together, I need a star there for that to match. So to start with, obviously, if any strings don't start with a star, then we need to start with those letters, just like this. So obviously, whatever matches has to start with A, and we keep going until we hit a star. So this will force characters up until all strings have a star. And I guess if we just split these up into, oh, okay, yeah, that's all it is. So all the suffixes have to, or all the prefixes have to match, and all the suffixes have to match. But aside from that, you can just string together whatever's between the stars, and you're golden. Okay, yeah, that's what I was missing. So anyway, that took me 5 minutes too long to figure out, but that's okay. So yeah. So yeah, the trick is whatever's between stars, we can just do them in whatever order. Doesn't matter. I mean, this kind of does look at first light like a a DP problem where you're finding some longest increasing subsequence or the longest matching substring, that kind of thing. But nope, it's actually just greedy in a particular way. So let's see, pattern.cc. Okay. Um, I do have to be careful of the case where the prefix and the suffix is the same. Oh, these are all visible verdicts. That's kind of nice. Um, so all of these, in all cases, okay, so I don't have to worry about the case actually where there's a prefix and a suffix. All of them have an asterisk. So that is one special case gone. So that's nice. Otherwise, you'd have to check and make sure like that your prefix and suffix weren't the same and that you were being forced to use just one string. Anyway, so this is fail. Okay. So really that should just, I don't even need that condition. Yeah. Okay, this is a bit ugly. There's probably a better way to write this up, but I'm on contest time. I'm not going to care. Okay, and we just put all the characters in between. And alrighty. Coconuts. Okay, so let's try some other cases. A star, C star, D. Oops. All right. Yep. Of course, this could be shorter because I could compress things, but I don't have to. So they don't ask for the shortest one. Okay. So they're all visible test cases, so I might as well just submit. And oh, wait, I've got an inline in there that I shouldn't. Bah. This time I was careful and I did read the input precisely. Okay. So that looks great. All right. This is a bit ugly, and there could definitely be a bug in there. Okay, nope, it worked. Let's move on. All right, Pascal Walk. Nice of them to start with an all visible test set question so that I don't have to worry. All right, Pascal's triangle. Interesting. So RK is the same as R choose K. Weird. Okay. We do have a hidden test set. So find a Pascal walk. Huh. Wait, this is trivial. Because you can just go along the outside. You can have all ones and then one non-one value, right? Yeah. The path does not even need to be of minimal length. Right, yeah, of course. I mean, that would be hard if it was of minimal length. So oh, I see the problem. Okay, the problem is that you need to get to a high number, like up to 10 to the ninth, with at most 500 walks. Okay. So I mean, you can do a row of the triangle followed by a bunch of ones, but you need to be sure that you're going to be able to get close enough that you need fewer than 500 ones to even it out, which I'm not sure you can do with 10 to the ninth. I mean, 1,000 is easy, so I'm not going to bother with that case. But I want to solve the hidden test case, the hidden test set. So you need to get within 500. And like more realistically, you need to get within like 300 or something, because you're also going to need some for the row. Now, is this always possible? I'm not sure this is always possible. So what happens if you have a row of Pascal's triangle? So say you've got 1, 4, 6, 6, 4. So you've got those, and those equal to 15, and then you go down 1. This is going to be something like doubling it, right? It's going to be pretty close to doubling it. So that's going to end up 21. Wait, that doesn't seem right. Shouldn't it be? Shouldn't it be double it minus this? What am I doing wrong? Oh, right. Sorry, I have the wrong value. Okay, yeah. So it's doubling this and then minus this value. Does that help me approximate it? Still don't really see how. I mean, I could just try the heuristic thing where I try walks until one of them is close enough. I mean, if you're trying, say you try 100 values that are all 10 to the 7th, you're likely to still be off by maybe 10 to the 6th, maybe 5 times 10 to the 6th, which is too much. Oh, wait. Oh, I'm being stupid. Rather than using the ones column, this is always just n. I can find a square number, which is, well, a triangular number. So this is going to sum to triangular numbers. So there's going to be a triangular number that's roughly within square root of 10 to the 9th of 10 to the 9th. So that's pretty close. And in fact, all I need are a certain number of consecutive values, like say 200 consecutive values that are, oh yeah. If I just divide it by 200, yeah, so when I take a sequence of numbers in this column, say I take a sequence of 200 numbers in this column, then if I shift it down one, I've added 200. So I can keep shifting it down until I am guaranteed to be within 200 of the answer. And wait, Wait a second, why can't I just pick n? What am I missing? I don't understand. Why can't I just output a single number? Oh, it starts at 1, 1. Okay, I'm totally off. Okay. Everything I've just said was wrong. Yeah. Okay. Kind of looks like you do just have to do some sort of hill climbing. So you can zigzag back and forth like that. In fact, zigzagging back and forth like that is going to get you the maximum possible value, because it'll be going down all the centers. And then you can subtract 1 if you shift this zigzag to this. You can subtract 2 by shifting this zigzag to this. That's going to be 10. That's going to be 20. That's going to be 15. So you can subtract 5 by going that way. So maybe you can solve it like a knapsack problem, where you're just finding, first you take the maximum possible value, and then actually the maximum possible value is huge, isn't it? You don't need to go nearly that far. They do have some interesting construction problems in this year's Google Code Jam. Yeah, I mean, if you zigzag all the way down, you end up with like 500 to choose 250, which is just a massive number. It's like 2 to the 249 or something like that. Maybe not that large, but it's pretty large. Now, you can't just go down the linear one. That's not going to be more than 10 to the 9th. Maybe you can just go down the quadratic one. No, that's still probably not going to end up. Well, it might. How do I do this consistently for all choices of n? What's a nice general approach I can use? I think I really just have to try a couple of things and just see whether they end up going over 500 in general. Although I'm not sure, like even if I test it for a few instances and see that they don't, I'm not sure. I would also need to guarantee that they never go over 500. Ugh. Oops, that one is right. So let's try an approach where I go down. I go diagonally along this column for a ways, and then I go diagonally along this column for a ways, and then diagonally along this column for a ways. So first I'm going to go down left 3, and then I'm going to do things to the down right, and then 1 to the right, then B things to the down right, and then 1 to the right, and then C things down right. So let's try. Yeah, so I'm going to do that times 3, and that times A, that times B, and that we'll see where that leaves us. Honestly, I kind of wonder if just a random walk would get this for me. A random walk at a certain level of the Pascal's triangle where you'd expect to randomly hit it. Well, whatever. So it's going to be 6 total plus A plus B. I'll just start with that. There we go. Let's just make this. Okay. Just don't want to overflow accidentally. Sorry, so I should be incrementing these. Oops. Okay. I mean, obviously, small things work because that's really trivial. So that's not close enough, or is it? Okay. Okay, we found a solution in this case. Okay. Okay, so that's still not good enough. Okay, good to know. So just greedily doing those 4 columns is not working. There's got to be some clever construction that just makes this trivial. Kind of half tempted to just submit the easy test sets and move on. Because I'm actually not seeing a good way to do the hidden test set. I keep failing. Problem is you have to get down in the range. You have to go down to the range of large numbers. But then as soon as you get close, you're in the middle of the large numbers and you can't adjust things. But what you can do is add a little loop in the small numbers. So like for instance, if I go all the way down, say I go down to the large numbers and I say, oh, okay, well, I'm close. And then I can look for loops that I can add. So instead of going da, 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 I can go da, da, da and add 5. where I can go da 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 and add 6. And there are plenty of those loops that I can add. So many loops. Yeah, I think that's just going to do it, actually. I think I'm going to have so many possibilities just from choosing all of these loops, and I can knapsack it. I can knapsack like 100,000. Actually, I might need to knapsack up to n to the 2/3, but that's still fine. Well, not quite. I'm not seeing a perfect way of guaranteeing that I can do it. So that adds 1 or 2. That can add 3. That can add 4. That can add 5. That can also add 5. Might be able to just do it greedily. Huh. How about that? So this is kind of cute. If I do a diagonal path down and I look only at the leftovers, sorry, I look at the the ones in the crooks of the diagonal. So I'm going dot 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 dot, and so I look at the one that's in this crook, and then the 3 that's in this crook, and then the 4 that's in this crook, dot 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 dot. So I look at those leftovers. So those are things I could optionally add without changing my path. And interestingly enough, I think the sum of these crooks is 2 minus the next one. Kind of looks like that pattern holds. Oh, actually, sorry, it's even better than that. It's at least two less than the previous one. And I can add an extra 1 here. So I can choose 1 or 2 here. And I think that's all I need. Oh yeah, sorry, if I count this one as well. Those just sum up. It seems like they just sum up to exactly 1 less than the next value on the right. So this plus this is 1 less than that. This plus this plus this plus this is 1 less than that. This plus this plus this plus this plus this plus this is 1 less than that. I think that means this is like a coin problem where I can greedily choose which ones I want, because I can always just make up for it. If I don't pick something, then I can always choose values from the previous set that sum up to at least that value. Cool. And I'm sure this makes sense if you could easily prove it on Pascal's triangle, but I'm just going to assume that it holds. Yeah, I mean, I can sort of see why it's true. Okay, so what I do is I follow this crooked path down. That gets me the maximal values. And I also keep track of the optional values. Okay. Okay, let's try this. No, I'm doing this wrong. Okay. Now I have to walk this back. How much time do I have? No, I've already spent an hour on this problem. Probably more than it deserved. Oh well. Especially if I get it wrong, that's going to suck. But we'll see. Okay. It's fine that that's an n squared operation. All right. So just for verification, for now, okay, so 1, 1, 2, 1, 2, that's not right. Oops. Oh, I have an off by 1 error. Okay. 3, 2, 4, 2, 3, 5, 3, 6, 6, 3, 10, 4, 20, 35, 70. Okay, so what I should do is try this for smaller values. Oh my god, really? So that did not work. Right. This should be if cur plus yeah. What the? Why is it crashing? Right. It should actually be slightly earlier. What's going on? Okay. So that looks right. So why am I getting this junk at the end? What the heck? 140. Up to 0. Oh my god. Wow. Oops. Okay, so that is working, I think. Let's try calculator again. 26 plus 126 plus 70 plus 56 plus 35 plus 35 plus 20 plus 25 plus... All right. Five, 10. Oops. Okay, so that's 510. That's a billion. All right. All right, I think we have a winner. So there's no risk of overflow, right? Got int 64s where it matters. Okay, I think we're golden. And using considerably fewer than 500 steps. Let's try it. Okay, well, it passed the 1,000, which is pretty good evidence that it's correct, because I only go up to 500 here. But it's not perfect. In theory, this could be wrong. My greedy rule could be wrong, but if my greedy rule were wrong, I would expect to fail on this test set. But I think my greedy rule is right. It actually just perfectly works out, which is kind of cool. I kind of wonder if this is going to be the intended solution, because this turns out to be a really elegant construction. I certainly flailed for a long time on that problem, but that's all right. Now, square dance. All right, let's try the third problem. You are organizing an international dancing competition. By the way, I could come back and test walk some more afterwards if I have free time, but I'm not sure I will. Since I spent an hour on that problem, I only have an hour left. All right. Okay. So we have dancers that are eliminated gradually. Now, they're up to 10 to the 5th, up to 100,000 dancers. So if they were eliminated one by one, I would not be able to get away with just simulation. And I mean, since this is the third problem, I suspect you have to be cleverer than just simulating this. I mean, this is not a hard thing to simulate. Now the question is it possible for it to last like 10 to the 5th rounds? If it only lasts, say, 100 rounds at most, well, it could be just linear. Okay, so if we take the highest interest level contestants, it could actually be balanced. The highest interest level contestant might not, for instance, in this case. The 4 is going to get eliminated, but the 5s are not. Okay, how about this? When I eliminate a competitor, then that's the only time when I need to update. Oh, okay, yeah, that's just going to do it. So, I mean, every competitor, there are going to be at most 10 to the 5th competitors eliminated. So if I just have to do 10 to the 5th updates whenever I eliminate a competitor, then I'm golden. So, yeah. So that's just going to require me to keep track of for each competitor who is its rightmost, leftmost. Okay, yeah. Okay. I don't think this is as hard as the second question, to be honest. I mean, I did flail a lot on the second question. Maybe some people didn't have as hard a time with that as I did. But anyway, yeah, so we'll have R and C. 1, 3. Okay. So this will be the round that they each live to. This will be the neighbor X. That's not right. That's not going to work. Okay. I like to line things up. Okay, and plus 1. Okay. I'll just make it all pretty. Okay, I think that's good for neighbors. Oops. Now, do all of the interest levels... Okay, all of the interest levels are at least 1, so 0 shows me that there are no neighbors. Oh, I still need to know how many neighbors there are. CV Okay. And I'm going to have a queue for okay, so that's going to be the queue for the people who expire the first round. Okay, so that shows that they've already expired. Okay, CRYX is equal to R. So they're expiring on this round. Okay, now. So I just need to update this guy's. Okay. Boy, this is ugly code, but it should work. Okay. So that should run in time. Now, so R is going to be the final number of rounds. Okay, if CR, that's that, then we'll pretend that they were eliminated in the final. Actually, wait. Yeah, I think that's right. And we're at plus equals CVYX times this should be just to avoid overflow. Oops, that's not going to be enough. And in theory, this could be up to like 10 to the 15th, but that's okay. We're still good. In theory, I think this is an answer. Oh, sorry, this should be +1. Because if they're eliminated on the 0th round, they still count for 1 round, and so on. Actually, this isn't quite right, because QX could actually have some stuff in it that's bad. Okay, so yeah, we stop as soon as there are no changes. All right, in theory, we have a solution, which should run in time. Okay, which is not right. So nobody got eliminated. Well, that's not good. 0, 0, 0, 0, sure. 0, 0, 2, 2, 1, 0. Okay. So that's correct. Then okay, those all look correct except for the final totals. So it shouldn't. That's not right. Oops. Okay. 16, 14, 14. That looks good. And for this problem, the visible test sets are really going to help test. So, oops. Wrong one. That would be embarrassing. Okay. So that one did not take me as long as the previous one, assuming I get it right. So, I mean, it is a bit complicated in terms of the code. I may have to do some actual debugging. Guess we'll find out. Wrong answer. Okay. So, so here we have 6, 12, 15, 20, 26. That appears right. Okay, so that's right. What if it's like something like that? So the 2 gets eliminated. First the 1s get eliminated, then the 2 gets eliminated, and the 3s get eliminated. 4, 8, 12, 18, 25, 29, 32, 39, 44. Okay, this all looks right so far. Wait a second. Okay. I think I see the problem. Suppose 2 things in the same column get eliminated at the same time. One of them is going to interfere with the other one, updating values. In fact, yes, I need to not only update this neighbor, I need to update the other one as well. Wait, but I'm already going to be doing that. This is probably the problem. I'm just not seeing why it's an actual bug. So if I update this first, oh, this seems fine. So let's see, how does this work? So if I've got, say, Yeah, okay, this is still right. Maybe I just have some bug somewhere. Ugh. So there's always the option of my writing a simulation and then finding a diff. That is going to take me another 20 minutes, though. That's going to suck. Well, I have screwed this round up on Screencast. It's immortalized forever. Hooray. Let's see if I can just spot the bug first. Okay. I need to test this only after I've done all the updates. That's the problem. Yeah, that's the problem, because it could actually be temporarily bad and then actually fixed by the removal of another neighbor. Okay. Ugh. Shadowing a parameter here. Don't like that. Okay. Let's try this much. This is the sort of thing that's really easy to simulate, but when you try to do the efficient solution, then there are complexities. So that still looks right. Okay. So yeah, the problem is that all of these updates, I mean, these updates are correct in the moment, but I need to do all of them first before I check whether any... Okay. Whew. God. That was worrying for a bit. It only took me 12 minutes to debug. It seemed like a lot longer. Ugh. Okay, cool. So I've got nothing left to do but testing. But it's round 1A. I mean, I don't really care that much, to be honest. Hey, Gennadi's doing this, even though the time zone must be terrible for him. I mean, that's one advantage of this time zone. It's 6 p.m. for me. The contest started at 6 p.m. for me, but like 1 a.m. or 2 a.m. for Russians. So a lot of the competition is gone. Not that it really matters. So I'm rank 611, which will increase because not everybody's going to get the hidden test sets. Not the greatest performance, honestly. It took me way too long to do this. I like my solution. It's very elegant. There's probably a less elegant, cheesy search or something that solves Pascal Walk faster. Something heuristic. I don't know. That square dance, I did pretty well. I mean, I sure didn't solve it in 14 minutes like Gennady did. But Gennady is just on a whole nother level. So, do I continue the screencast and do some testing? I mean, I didn't really test Pascal Walk that much. I could do a bit more testing. I'm trying to think, how can this be wrong? So this could be wrong if for some reason I've screwed up and I'm making an invalid step. By the way, in case you're wondering why I never add like stood equals C++ 14 and -03 and stuff like that, I've got that already aliased into G++ because I am never not going to compile with -03. So yeah, always use -03. Although I think contests tend to use -02 in the actual. Actually, I'm not sure about that. I think the finals environment uses -03 for compilation. You'd have to check the rules, but I think that's the case. So yeah, always use -03. So I mean, my combination code is not going to be wrong. I think that's pretty dumb, pretty straightforward. So as long as this matches, and as long as I'm not making any steps that are invalid, so you can go +1 or you can go +1 or +1 in one of the two directions. I mean, I'm only going down, so there are only 3 directions to consider. Actually, sorry, there were 4 directions, because sometimes I go backwards. Yeah, I mean, that's all correct. I mean, I could just try random cases and see if it ever fails. could use an assert there, but whatever. That's just a check for the illegal direction out of the 8. All right, this is all just working. All my random cases work. Yeah. Well, you saw me do some testing, so yay. Which I didn't really think I was going to do for this round, but that's all right. Oops, I have my full history saved. I don't want to get rid of the working solution. All right. Cool. I think that's it for this screencast. Yep. I mean, I don't really think square dance is likely to be wrong since it passed the small case. Generally the only way you'd be wrong from the small case to the large case is if you run over time. But my solution, my solution is linear basically, so it's not going to run over time. So I'm pretty confident that I will get both right. Anyway, I guess I will see you in round 2. Maybe I'll tune in for rounds 1B and 1C, but you won't see a screencast for me. I mean, I'm not even eligible to compete in them. But yeah. Okay. If you're still watching, thank you, and good luck with the Google Code Jam yourself. Bye.